I wore it for a week. I wore it in the rain, I wore it washing my hands, no signs of any leaks. The assembly held together great. I was fully expecting it to pass the pressure testing, no issues, but the reality of manufacturing is hardware is hard. All the gaskets were designed to spec. They all assembled smoothly and clean. They all held snugly in place. But the issue isn't with the design, it's with the machine that made the design. And more specifically, with the X-axis right here. This is a gantry style mill. And what that means is the gantry needs to be perfectly square with the base to run true and square. This side of the gantry is pushed back and torqued just ever so slightly. What that means is this ball screw has a couple very small tight spots in it. And I've tried to work on that. I've shimmed this out a little bit. I've gotten it as good as I can, and I've even adjusted and compensated for it in the software. But the reality is it's not perfect. And so the X-axis is always just ever so slightly, like maybe 15 or 20 microns out of square from the rest of it, which normally wouldn't cause an issue. 99% of use cases, no issue. But for this, it seems that it's affecting it. So to rebuild it, I would actually have to tear the whole thing down, remove it from the base, which would take a month because this is a big heavy beast. I would have to pull it all apart, which would then turn into other upgrades. And I'm just not gonna do that right now. So what I am gonna do is I'm gonna work within my machine's limitations, and I've worked on updating the design so that it uses O-rings rather than gaskets. Let me show you here. So you can see here, it's now using a clamping force rather than pressure outwards. The rubber has more give to it than the gaskets did, and so they should be more forgiving on machining tolerances, and the whole thing will sandwich together and be held together with a screw, with a fastener. And so I'm going to work on updating that, and we'll see where it goes from there.